So welcome everyone to the SIG Cloud Provider Deep Dive, where we're going to talk about testing cloud controller managers. And a little bit of an intro here to start with. I'm Michael McCune. I'm a software engineer at Red Hat, where I work on cloud providers and also cluster autoscaling and whatnot. And Bridget?
Yeah, I'm Bridget Kromhout, and I am a product manager at Microsoft, SIG Cloud Provider co-chair. Focused on lots of upstream open source CNCF stuff, very exciting. And yeah, Walter?
Hey, I'm Walter. I'm an EM in denial. I still pretend that I'm a SWE. I would like to keep pretending that I'm a SWE, but unfortunately sometimes I do actually have to act as an EM. But
Take it away, Walter.
all right, so history time. SIG Cloud Provider has started as a working group. Tim Hawkin came and with a few other folks said, hey, our code base at Kubernetes is getting very complicated, and this is before it got nearly as complicated as it is today. And a lot of that complication has to do with Google and, well, others, but largely at the time Google.
You can say that because you work at Google.
I work at Google. I'm allowed to take the blame. But the cloud providers had a lot of cloud provider specific code. And you know, anyone who's looked through what happens when you want an IP address for your node, or you're trying to work out the node isn't responding anymore, is the VM under it still in existence, is quite familiar with how much actual cloud provider code is needed to make all of this work. And every time we added a new cloud provider, that complexity went up. And so the general premise was, let's stop. Let's just stop. No more cloud provider code in KK. The problem then is now you've got two classes of people operating. You've got someone who's in tree and gets to do things, and then you had a lot of secondary cloud providers who weren't in tree, and it was fairly unfair to them. And so we started, and we've been working very hard, and as of, I think it was about a year ago, we deleted over 1 million lines of code. All the cloud provider code is gone. It's out of KK.
I mean, red diffs are good diffs, right?
Yeah.
Yeah, and I mean, if you look at like this little timeline we've put together here, you can see the process of how long it took us to do this. Going back to what Walter was talking about, this cloud provider code has existed as part of Kubernetes since the 1.0 era, and around the 1.13 time is when these decisions were made to start saying, okay, we need to start getting this stuff out of here. And you can see it took us until 1.31 to actually finally get there.
And it doesn't mean that nobody put anything out of tree before that. They certainly did. It's just there was still some in-tree code that hadn't been completely removed, and so every time there were CVEs, all right, we fixed the out-of-tree one that we're currently working on, and also let's port some patches into the in-tree. Like, that was obviously unsustainable.
Yeah, and so like a big part of the SIG Cloud Provider from the beginning was this extraction and migration effort, but something else we wanted to highlight as well is there used to be an SSH tunnel built into Kubernetes as well. And the SIG has created or helped, I guess, host the API server network proxy. And I don't know if you want to mention like where we're at with that.
Yeah, I mean, so whether you're aware of it or not, it's not a required piece, but the API machinery code, when the Kubernetes API server wants to talk to your cluster, it needs to be able to route traffic. And depending on how your cloud provider works, there are differing ways for that routing to happen. Excuse me. And so I know Google, but I believe even IBM and Microsoft have some use of this system known as the API Server Network Proxy that takes the traffic from the Kube API server and routes it cleanly through and drops it into the actual data plane of the cluster. And so the reference implementation for that is actually owned by SIG Cloud Provider and allowed us to remove the very unfortunate SSH tunnel code that preceded it.
Which is probably a good thing. I mean, we don't need more backdoors to anything.
Right. And so we've taken all this code out, we've got everything migrated, we've got the API server network proxy, like we're all done now, right? We can just call it quits and go home, right?
Declare victory, right? Talk over. No, I mean, not really, right? Like there's a lot of places that we still have work to do. Whether it be the API server network proxy that, by the way, if that sounds interesting to you, is a code base that we would welcome participation in. And I think probably looking at the migration retrospective gives you also an idea of the kind of stuff that the SIG does.
Yeah, and I think one thing I want to go back and like put a PR into the migration retrospective to cover the 1 million lines of code, because I think we didn't quite understand how much was removed from the source base when we did all this, and I'd love to go back and highlight some of that. But there are other things we'd like to think about for the future.
Yeah, and I think this starts to get to the question of what is the mission of our SIG if our SIG originally started focused on this extraction migration and now we're like mission accomplished, we're done. But we're not actually done because, as we'll go into some detail talking about, we have both areas of intersection with the rest of Kubernetes. Like, for example, API server network proxy, it's SIG Cloud Provider, but it's also SIG API machinery. And there are exciting new open source projects. Maybe I'll let Walter tell us a little bit more about Crow.
Well, before we get to Crow, which I definitely do want to talk about, one of the things to remember about that million lines of code is it wasn't all production code. There was test code in there.
So many tests.
And there are tests which require cloud provider code to be able to run. If there's no cloud provider code, those tests can't be run, at least not off of just what you built in KK. So we still have some homework to do, and that is, how do we make some fundamental tests? Both Bridget and Elmiko are tired of my example, but does kubelet work if you restart the network? Seems like something that should work, but every cloud provider implements node differently, which means that the mechanism you need to restart the node is different by cloud provider. To restart network is different by cloud provider. So that is a cloud provider specific test. You can only run that test if you know which cloud provider you're running against.
Yeah, but back to the idea of there's a lot of things other than the testing, which is the rest of what this talk is going to focus on, but there's a lot of things that we see as we need to investigate what should this SIG be doing.
Absolutely. And so Crow is, thank you. Yeah. Crow is this great example, right? The idea behind Crow is, if I want to generate a CRD as a platform engineer, so kind of shifting things a bit, I may want a very nice, simple API to be able to generate something like, I don't know, my workload, right? And that workload may need a database and a web server and some roles and load balancers and storage devices, and I want to give this to, or an ML workload, and I want to give this to an app engineer or an ML engineer and say, look, the only thing you actually care about is the name of your workload, some sort of size, t-shirt sizing estimate, and the image. And I, the platform engineer, can take those 3 or 4 parameters in a CRD that I've given you and automatically expand those into half a dozen or a dozen other systems. And in fact, on top of that, that database that I just mentioned, even though the rest of the workload is Kubernetes native, that database maybe is actually something that's provided by Microsoft or it's provided by Amazon, and I have an existing controller that if I generate the right CRD using something like AICK or ASO, already knows how to go and create that database for me. And so the idea behind Crow and tools like it is to make that a lot easier. And especially when you start looking at KCC, ACK, and ASO, those are Kubernetes native ways to control your cloud provider, but they're complicated, they're difficult to use, and how do I make those integral to my workload? And so this is sort of a possible way we could go forward. It's a first draft of how do we make cloud provider code the same kind of workload as anything else that I'm doing. It's handled in a Kubernetes native fashion, just like anything else, and done in a way that is simpler to use than what has come before it.
And so this all sounds good, but how do we make sure it goes well?
Yeah, and before I step on here, though, I just want to say, like, this has caused us to think about the SIG charter. Because if you look at the SIG charter the way it's written today, a lot of it talks about the extraction and migration, and we never considered these other use cases that are cloud provider specific. But yes, as Bridget is calling out, today, though, we would like to talk about testing. And why do we want to talk about testing? Because testing is the coolest thing you can do with software, right?
It's so awesome.
Yeah, it's super fun and everything. Well, okay, jokes aside, like Walter said, we lost some tests during the extraction and migration process, right? And now we have new cloud providers who are part of Kubernetes that weren't necessarily part of the original in-tree code. And they have different features and different ways to express these things. And so we would like to look at testing as part of the next phase of what SIG Cloud Provider is getting into. And so, to look at why this is important, we're going to throw up our nice data here, and I think Walter's going to tell us a little bit about how we've been getting better over time.
Yeah, and I think this is a very interesting chart, and thank you for Jordan Liggett for generating it for us. But this is looking at how many regressions were discovered at a particular month after a particular release goes out, right? And so we look at 119, and at month 4, we're at 16 regressions, which is pretty terrible. That's why it's red. We have had other releases that were a lot better, like the 127 release. At month 4, it looks like we were at about 8 releases, or eight regressions. So, this is an overall, this isn't cloud provider specific, it's not looking at any particular SIG, but if it definitely suggests that there have been times where we've either gotten lucky or gotten the testing right, and there have been times where we haven't gotten lucky or we didn't get the testing right. And so we want to work out how to be both luckier and getting the testing job done correctly. And one of the things is, we're not trying to replace SIG testing, but we do want to work out if SIG testing is getting us the right tests and getting the test done in KK when you don't need a cloud provider, how does SIG Cloud Provider help SIG testing when you do need the cloud provider? And so we're actively looking at how do we solve that problem? How do we get the tests run when you absolutely require a cloud provider for the tests to work?
Yeah, and what we want to see is what this chart is showing us, which is that if you look at it reading across the, rows it would be, we can see that post-release we're starting to get better. And we postulate that this is based on the idea that we're adding more tests to Kubernetes, we're making it better over time. So seriously, we think this is pretty important. Bridget, why don't you tell us about why this is important to our users?
Yeah, I think it's because if we add new features, they need testing for there to be end user confidence and operator confidence in the fact that we're actually delivering what we say we do. And it's also really important, and there was in the keynote this morning, I thought it was really interesting, this idea of, European cloud sovereignty and making sure to fund and allow for specific geo-placement of exactly where you want your workloads to be and that sort of thing. If we don't have good tests and configurable modular tests, it's not possible for a new cloud provider or even an existing cloud provider's geo-specific area to test accurately. We need, instead of that past where we had the specific KK, the tests in KK, and then some also rans. No, we need everyone to be a first-class citizen of getting their tests run, as well as all the other ones. And I think, let's see, probably Another way to think about this, and I think this is important too, and maybe from a Red Hat point of view, this would be interesting to hear your perspective, Mike, is that not everyone is using Kubernetes packaged up for them exactly by one specific provider. Like a lot of times people have different distros or even ways that they use it, non-commercial releases, et cetera.
Yeah, and this gets into a concept that I think, Walter kind of introduced me to, and I'd kind of like to turn things around and say, like, when we start to talk about Kubernetes and we start to talk about all the different cloud providers and how you put these things together, there's a natural question, which is, why can't we just do all of this testing in KK? Why, okay, we extracted the cloud providers, but why can't we do all the testing there?
And one of them I mentioned before is, networking. If I want to shut down the network and start it up again, one, we have the fundamental question, is it Linux, is it Microsoft Windows? But no offense to Bridget, let's just pay attention to the Linux for a second.
Yeah, Azure is very Linux focused.
This is true. Is there one way in Linux to shut down a network? And in fact, you discover quickly that, service network stop, service network restart doesn't work on all Linux distros, right? And so a lot of these assumptions that you might think are really easy will work on some cloud providers, but not all. And it gets even worse. I know there's a big thread going on right now in other parts of KubeCon on what are we going to do about load balancing and networking, right? And if there is no one true way of doing load balancing or what load balancing means. And so when you want those load balance tests, we don't have the new load balancers necessarily turned on by default. You've got to pick your solution, and does do the various things that need load balancing work with load balancing correctly? You want to be able to test, hey, does this service that I need work correctly with the load balancer from this cloud provider? And this is just a repeating pattern. We see it with elastic storage, we see it with load balancing, we see it with IP addresses. We see it with the way that even things like, API server network proxy that we own. Some cloud providers use it, some don't. It's out of tree. It has core key hooks in the Kube API server and multiple ways that it can be configured. Does it do HTTP Connect? Does it use gRPC? Each of these are very cloud provider specific and are based on things that don't exist inside of KK.
And it sounds like Walter is describing a giant, complex, exponential complexity text matrix that sounds suddenly almost unapproachable. Like, how are we going to solve this?
Right. So we have an idea, and we've formed it into a 3-step plan of kind of how we'd like to proceed and make this better in the future. So one of the things we'd like to do is encourage more providers to participate in Kubernetes. We see more providers coming to Kubernetes every day, and we want to make an on-ramp that makes it easier to get into the cloud providers, the cloud controllers, and into this testing world. And then secondly, in order to do this, we need to refactor the test suite that's there for a lot of the reasons that Walter was just talking about. Previously, these were all scripts that lived in the KK repo. And so to turn off the network, device on an instance running on GCP, that's a different script than it is for Azure. And so now we have to understand, how do we make this modular for the future so that as someone like IBM Cloud is joining us, that they can do the same type of thing and repeat the same type of patterns, and we can use common tests to do that. And then the third part to this, and this is always the part that we're bad with, is kind of the end part of the maintenance, right? We need to support those communities once they come and start adding things to Kubernetes. So as new cloud providers come to Kubernetes, as they create their cloud controllers, as they get involved in the testing, we need to make sure we're there to support them and continue to make sure that they can have a good experience in the community. So now we're going to dive in a little bit deeper, and we're going to start by talking about what does it mean to get a provider involved in this. And so, Walter, I'll hand it over to you.
So one of our basic things is we provide a repo, right? And there are a lot of them. There's SIG Cloud Provider AWS, SIG Cloud Provider Azure, SIG Cloud Provider GCP, SIG Cloud Provider Huawei, right? There are a lot of these repos, and the idea here is it is a place that we can, one, put a lot of the CCM specific, there's the CCM, Cloud Controller Manager. That's where the controllers you need for your fundamental piece can live. And you can build your own CCM binary that is for managing your cloud provider code. But that's just the beginning of the story. We need, anything you need for the artifact registry. Do you need special tokens for your artifact registry? Do you have your own CSI drivers? Do you have something special like, are you pulling in the API server network proxy? Do you have your own cert manager, which is not the CCM, but is in fact yet another controller manager? Or your own load balancer, not looking at anyone in particular, your own load balancer controller that is separate from the CCM, right? Somewhere there needs to be a place where all of the bits that are needed to get your cloud provider, not a GKE, not an EKS, not an AKS, but just a cloud provider distro that we can test as open source that Kubernetes works on your cloud provider. And so if you come to us, the SIG Cloud Provider, we can provide you that repo, we can provide you guidance on how to put it together and how we can then make that, so that it builds, it creates a cluster, and that cluster can then be tested by the system that Bridget and Elmiko have been talking about.
And if that sounds like a lot, take a look at we have an actual, QR code there that goes, and the slides are also going to be published, that go to the specific example of IBM Cloud, walking through exactly everything Walter just described.
Right, because in order to do that, we need the cloud providers to become involved in the CNCF and to be able to give us, or not give us, but be able to share with us the hardware so that we can run these tests, right? And I want to give a big shout out to the IBM Cloud folks because they just finished this process, and there's an issue here on the right-hand side QR code that shows how you bring a new cloud provider into the test infrastructure. So if that's something that sounds interesting to you, please check out those things. But let's get a little bit deeper into like refactoring the test suite and what that means. We talked about bringing up and down network interfaces. We talked about like node life cycling and those kind of things. This is different on every cloud. And in order to make a future where people can come and kind of have a self-service experience where they can work on their repository and then commit those changes and share them with all the test infrastructure, we need to be able to refactor the test suite so that we can distribute this functionality, so that we can have a common test that says, when I drop an interface and bring it back up, what happens? Does that work? And each cloud provider can then say, yes, I can do that, or no, I can't do that. And then they can actually give the functionality to do it that way, so that we can start to make these more modular over time. And what I want to do is dive a little bit deeper into these tests. And I want to kind of like ask Walter here, so, we talked about node testing, we talked about dropping interfaces and whatnot. Like, what are some of the other problems around that? What are some of the other details that we need to get into to do this type of testing?
I mean, it's a great question. And the subtlety here is sometimes we don't know until we hit it. So, I mean, throwing my parent company under the bus, we have a rule that says images that you want to run have to be in gcr.io. And we have tests that have been written, I can think of a particular one from Red Hat, where the image that you want to run lives outside of gcr.io. Well, our admission controller on the Kube API server just went, yeah, no, you're not allowed to run this image. Sorry, not going to happen, right? And it sounds like a simple thing, but that means someone, I mean me, had to go and find the source code that David Eads used to write that test and build that image, and I had to go and read the source code, make sure it was good, work out how to compile it, and register it to gcr.io. Everything else about the test is the same. It's just that image path, right? But it can be as simple as something like that that causes an image to work on one cloud provider and not on another.
And I think I wanted to highlight that Walter and Almiko here are giving us a really good example of the cross-organization collaboration that's possible in this SIG and in CNCF in general. Like I would say, we've run into a number of bugs with the way that Azure Cloud Provider, for example, worked that were brought to light by Joel, at Red Hat on Michael's team, and it's fascinating to see that when you have that perspective, we're doing something and it just works. Well, if somebody from a different, even configuration of network or whatever turns out maybe it doesn't work. So I love that cross-pollination of testing and ideas.
And so we're talking a lot about networking. We've mentioned this network interface case a bunch of times because it's kind of an easy one to think about. But another one to think about in the similar light is kind of the node lifecycling tests, right? There is a controller in Kubernetes that talks to the underlying cloud and says, hey, does this instance still exist? And if it doesn't, we should delete the node object and make sure that the API server is updated and everything. And this starts to get into what we now need to do to make these tests better, is that we've had this process where we've extracted everything. And in order to not slow down Kubernetes releases or to impede them, we've had to make choices where we said, well, this test only runs on one platform. It's not a very good test the way it is. Let's pull it out so we can keep the process moving. Now we need to go back and start auditing these things. And this is kind of what we're talking about here when we get to the deep dive section, right? There are different things that we need to do for every piece of this. And the node part is one part of it, but there's also service tests we can talk about too.
We're possibly a tiny bit short of time, so I don't know if we'll go into a ton of detail about service tests, but I'll just say that if we're thinking about a service, and we're thinking about service health, it's like...
And load balancers.
And load balancers, and have any of you all experienced, our error just returns 200 okay, and it's like, no, that's not a good error.
Yeah, so... In the interest of time, I'm going to skip over these slides here, but I recommend that if you're really interested in understanding the functionality of the different parts of the cloud controller, we advertise in the Kubernetes documentation that cloud controllers do a certain thing. And we need to make sure that we're testing those and that they do them or advertise that they don't do them so that users know what they're getting into when they get into these things.
And so it's actually testable.
Right, and it's also important to note that each provider might have specific tests that they want to run that are unique to their provider that don't exist on other providers. And we need to make sure that there is an opening for them to do that type of testing and have it all connect to PROW and all the other good things.
And the other thing I would mention, just a thought exercise. If this testing happens with release, that's every 4 months. If it's broken after you haven't run it in 4 months, how hard is it to find the issue? And if the answer is very hard, and I think it is, then the question is, how often do you need to run the tests so that you have confidence that it's a lot easier to find the change that broke your cloud provider?
Yeah. And one more thing to highlight here, and just to kind of pose this as a question for everyone here to think about, and Walter mentioned it earlier, and as we talk about different clouds, different deployments of Kubernetes, there are different operating systems running, and how much of these details do we have to become aware of in the metadata around Kubernetes? So I think the last part of our 3-part plan is to support the community. And this kind of goes into how we're going to document the tests and do all those other things. And I think we're running pretty short on time, so I'm going to accelerate to the what's next part, because that's really, the exciting part here.
And this is exciting because this is, where are you going to jump in and get involved? And maybe you're spinning up a new cloud provider, and that's great, but maybe you just want to get started contributing as a contributor, and you want something interesting and great to start working on. And we have a number of interesting problems that we put our heads together and thought, okay, let's start with what does it mean philosophically to bring up a cluster?
Right.
What does that even mean?
And this is where Walter and I are going to have a COPS and cluster API kind of wrestling match or something, right? But these are questions we want to solve, right?
It is. It's absolutely one we want to solve. And, we don't need to solve, we're not trying to do a matrix test, right? But we are trying to make sure that a representative GCP cluster is tested. A representative AWS or Azure cluster is tested. A representative Huawei cluster is tested.
Yeah.
And I think that the other place that's really interesting there is we don't know what we don't know. But I bet a bunch of you folks, watching this live, watching this on the recording, can find some gaps in the testing and figure out where are we making incorrect assumptions and missing a test. At this point, we know some are missing.
Yeah. And, if you're watching here or listening at home or watching later, bring us your good ideas. We have an enhancement draft, and I'll switch to the page with all the cool QR codes on it. We have an enhancement draft that's currently up that we're trying to figure out these questions about the tests. And we want to make an enhancement that goes into Kubernetes in parallel with how we're building proofs of concept to show how these things work. And so I think that's really where we're going to need help next, is building these things, helping us with the enhancement, and kind of looking at the future of SIG Cloud Provider.
The other thing I would like to mention, and this isn't necessarily obvious, so I want to make it clear, SIG Cloud Provider GCP is not owned by Google. SIG Cloud Provider Azure is not owned by Microsoft. SIG Cloud Provider AWS is not owned by Amazon. They are owned by the CNCF. They are owned by Kubernetes. They are owned by this community.
Yeah, they are in Kubernetes SIGs, like literally the Kubernetes SIGs organization.
Absolutely. And that means that if you are a customer there and you're like, hey, I want this tested, that doesn't mean, oh, I'm not a cloud provider, I can't participate. Come to our meetings. We will help you get involved in maintaining the repo or the distro that is important to you, right? This is not only cloud providers are allowed to show up to these meetings. That's not true.
Yeah, and I'm already wearing my hopeless optimist cap, so I will keep it on for the moment, but I want to see a future where cloud providers and non-cloud providers and community members can come to this SIG Cloud Provider activity. They can see a rich set of testing. They can understand bugs that are happening on a platform that might be their favorite platform. And they can say, you know what, I can make a contribution, and the people who are maintaining these pieces of code can understand that my contribution is to be trusted because I've written the test. I've demonstrated how the failure is happening. And now I'm creating a pull request to show how we can fix that problem. And so I want to see a future where more people can get involved in these cloud providers, not just someone from AWS or from Google or from Azure or even just from Red Hat. I would love to see community members who are using these things, finding the bugs, reporting issues, maybe showing us in the tests how it's broken, and then proving that it can be fixed with a pull request. So that's my dream for the future.
I love this dream, and I agree with all of it, and I also think that we should probably anticipate that where can folks come, I believe it's tomorrow at lunch, to the SIG meet and greet.
That's a great point. There is a SIG meet and greet tomorrow, and we will have a table there, and you may see one or all three of us hanging out there, and come talk to us and ask questions and get involved in the community.
And we also, of course, have our regular SIG meetings. It's all on the SIG information.
Yeah, and if you feel so inclined, the bottom QR code is for feedback for this session. We would appreciate anything you'd love to give us comments about. Are we all set on time then?
I think we're good.
You got questions? Yeah, does anyone have questions?
Yeah, well, we're happy to answer questions.
Hi, thanks for the talk. I'm really curious about those repositories that you mentioned, and I was wondering, I'm still not quite sure I completely get the picture, but the idea is to basically have certain tests which are provider specific, right? Have you thought about how this will scale with probably many more cloud providers than you have right now?
Yeah, absolutely. So like what myself and a colleague have been investigating about building a proof of concept around this is that ideally what we want is tests that live in the KK repository, right? Common tests that all cloud providers can share. For example, the network interface drop test, right? But what we want to do is build an interface that allows each cloud provider to implement a specific concrete version of that from their cloud provider repository. So the code is not back in KK, but it uses those interfaces. And then when the test is running, right now, if you look at the tests in our end-to-end suite, they have things that say like, skip unless platform is, and then it, has lists some platforms. We want to invert that. We want to have an interface where the test can ask the implementation, do you implement dropping the network interface and bringing it back up? And then the test implementers in the cloud provider repository can either implement that functionality or not implement that functionality.
And I will add to this, this is a working mechanism today. So not on the test side, but in the actual controllers themselves. So if you look at something like the cloud life, or the node lifecycle controller, it can take it lives in KK, it has an interface to the cloud provider, and so it does nothing in KK, but when you compile that piece of KK into the CCM in the cloud provider repo, it can take a cloud provider implementation and that interface has a question like, does the VM still exist, right? And so the idea is to take that same sort of mechanism and extend it to not just be for the runtime, but actually also for the test time.
Yeah, and you can see a great example of this. I was going to give a shout out to SIG Storage, but I don't see Jan in here anymore. Maybe, Jan, if you're here, raise your hand. I don't see him. Anyways, I would look at the tests in KK in SIG Storage because they've done a beautiful job of this with the CSI testing. They have common tests in the KK repo, and all that each individual CSI driver has to implement is a configuration file. Now, their setup's a little bit different than ours, but I think it's really elegant, the solution they came up with. And to the scaling, yeah, we just have one set of tests, and you combined it with the CSI storage repo for that driver, and you can make it work.
The other thing I'll mention on sorry, Bridget. The other thing I'll mention on this scaling is there's a couple of dimensions of scaling, right? So one is, how many repos do we need? I don't know. It's a great question. We have dozens, I think, at this point, but I'm not sure how many more we're likely to need. The other part is how much testing we need. And so one thing I will say, just flat out, is we're probably going to have a different kind of test run models, and it's going to be up to a cloud provider to volunteer compute time to be able to run the tests at a given frequency for them. And this is where I start talking what I mentioned earlier, which is how often would you like those tests to be run? How difficult do you feel you're willing to accept it being when to debug why a test failed?
All right, I think we're at time, so we'll leave it at that. Thank you all so much for your questions. Thank you to my co-speakers.
Yeah, thanks.